In example 4, we're going to use Newton's method to find all the roots of 7 cosine of x equals 6 minus 3x, correct to 6 decimal places. And the first thing, of course, again, is we need to have the function equal 0. I can either move the 7 cosine of x to the right or the 6 and the 3x to the left. It doesn't matter what the function looks like as long as it equals 0. I'm just going to take everything to the left. I prefer that structure myself. So 7 cosine of x minus 6 plus 3x equals 0. So f of x is going to be 7 cosine of x minus 6 plus 3x. Therefore, f prime of x is going to be the derivative of this, which is negative 7 sine of x. Derivative of cosine being negative sine. The 7 is just a constant multiple, has no bearing on the derivative, so it just comes along for the ride. Derivative of negative 6 is 0, and derivative of 3x is, of course, 3. So I'm going to let this be y sub 1 and this be y sub 2. And as I said, I'm going to show you guys the easiest way to do Newton's method that you can find. And that begins kind of like the last time we did it, where we're going to type in y equals, and we're going to enter our y1 and y2 as the function and derivative. I do want to make sure I'm in radians when I'm doing trigonometry, so make sure to look up the top. If it says radians, fine. If not, hit mode, and you can switch it to radians there. So if I go to y equals, enter function 1, it's 7 cosine of x. Every time you do trig stuff, once you've established cosine of the argument, make sure you put it in parentheses to end the argument, minus 6 plus 3x. Enter. And then the second, the derivative, so y sub 2 is going to be negative 7 sine of x, end parentheses, plus 3. Right, so function 1, function 2 are entered. So the easiest way to do Newton's method is as follows. You, first of all, says find all the roots. So let's start there. I'm going to go here. Every other time we've just been finding an answer. This time they're asking us for all the answers. I'm going to turn off function 2 real quick, and I'm just going to do a zoom 6, standard viewing window, negative 10 to 10 in all directions, just to get a feel for how many answers there are and what they're close to. So 1, 2, 3, and that looks like it. So looks like there's about 3 answers. One's a little bit less than 0, one's between 1 and 2, and one's between 3 and 4. If I wanted to get a closer look to get a better guess for each one, maybe I go from negative 1 to 4, and then I'll get a closer look. Maybe about negative 0.25, maybe about 1.2, and 3.8 maybe. The initial guess isn't as important as anything, but when there's more than one answer, if you guess near an answer, it'll probably find that answer. If you guess near a different answer, it'll find that answer. So you kind of want to guess close enough that you're picking answers close to what you're looking for. So I'm going to have initial guesses of x sub 1 is equal to negative 0.25. Oops. I can go 2.6 also, it didn't really matter, but 2.5. Let's go with a guess for the second one as maybe about 1.2, and the third one maybe about 1 or 3.8. So here is the easiest way to do Newton's method. Once you've gotten your functions typed in, and even if it's turned off, it doesn't matter. That's fine, but just make sure they're both entered. Function, derivative as y1 and y2. You go in your normal calculator screen, hit the program button, and you choose Newton, which isn't on here. Dang it, let's see. Hopefully it's in here. There we go. It'll be one of your programs on yours, but we're loading Newton, so hit 1 for me. For you, it's probably something else. It'll say program Newton, hit enter, and it wants to know your guess. So my first guess is negative 0.25, hit enter, and then your calculator goes ahead and goes through the iteration process. And the very bottom one, the way I wrote the program is I said if the next one equals the previous one, stop. So once it stops, that means that's correct to that many decimal places. So the correct answer is negative point, and it wants 6 decimal places. So x equals negative 0.256811. Second answer. So if I hit enter, it immediately opens the Newton program again. It wants your second guess. Enter, and 1.238224. And our final guess is 3.8. Hit enter third time, put in our final guess, 3.8, enter, and it's going to figure out that it's x equals 3.818648. In all cases, round if necessary, round up. Each case the number was less than 5, so we just kept it what it was. Even if I guessed something crazy like 65, it will eventually find an answer. It's jumping kind of all over the place right now. There we go. It found that one. So but I can't guarantee it's going to find that one. So if I'm guessing close to the actual answer based on the graph and kind of getting an idea of where the answers are, then it kind of zooms in on it. That took about 50 iterations to get where I was going, and it got me to this one. Maybe negative 24 might get me to the negative one, but maybe it won't. It actually did. So, but again, there's no guarantees as far as where it's going to go. So by guessing close to the answer, it's going to find that right thing for you. The reason I wanted you to see the other ones before I showed you this is because some of our programs have been disappearing from our calculators, so I wanted you to have the ability to do it without the program, just so you can see the program, what it does is exactly what we've been doing. X minus y1 over y2 is x, so your guess is entered as x, and then x minus y1 minus y2 is stored as x, then it displays what x is, and if that equals x, doesn't equal x, go to 1, otherwise it stops. So once this equals x, once the guess and the next number up is the same, it stops. That's the whole program. But you don't have to write the program to be able to do it. Just know that that program works, but if the program disappears, what we've been doing in class also works. So I would do it this way as long as my program is alive and well. If the program ever dies and you don't have a chance to get it put back on your calculator, you can always do it the other ways until you get it put back on your calculator.